And here's the question. What is the force on the 3 microcoulomb charge due to the other 2 charges? When they say charge, they mean point charge. So here's 1 point charge, second one, and the third one. So I'm actually going to call them that too. I'll call this one Q1, Q2, and Q3, just to keep it more organized. So this would be like 3 students, one here, one here, and one here. And this student is the one that could get pushed away or pulled away by either that one or this one, okay? So this one could move. You guys, if we've got Q1 right here that can move, what's Q2 going to do to it? Is it going to push or pull it? So is Q2 here going to pull it this way, or is it going to push it that way? It's going to pull it towards it, because opposites attract. And then these two here, Q3 and Q1 are the same charge. What's going to happen? It's going to push it away. So that charge right there, Q3, will push Q1 that way. So you now have the directions of the forces. So you have 2 forces between these 2 and between those 2. And you know that this one here is going to push it that way. So I'll call this one F3. And you know that this one is going to pull that one that way, and I'll call it one F2. This one's not going to move, that one's not going to move, but that's what's going to happen to this one, okay? So F2 is going to pull that one that way, and F3 is going to push that one that way. Does it make sense? Okay, so now we just have to calculate the forces. So what is F2, which is between these 2, and what is F3, which is between that one and that one? So let's do it quickly. F2 is the force between Q1 and Q2. Just to clarify, F3 is the force between Q1 and Q3. And then just to clarify more, F3 is to the left, so it's that way. And F2 is to the right. So we've got the direction thing worked out. We don't need to concern ourselves now about the positives and negatives. You could put the positives and negatives in the equation. You'll get an answer, but really it's the absolute value you're looking for. You're looking for just the magnitude because you already know the directions. You know you're going to get an answer here. It could be 10. Answer here could be 5. And you just go 10 minus 5. Okay. So now we're going to calculate what those forces would be. I need you guys to use your calculators and crank them up pretty quickly. So F2 is K Q1 Q2 over D squared. And I'll push this one. So K Q1 Q2 divided by D squared. K is 9.0 times 10 to the 9. What was Q1 again? That's K. Yep, always. What's Q1 on your diagrams, guys? Yep, exactly. 3 times 10 to the minus 6. And then what's Q2? It was, from your diagrams? 6, right? 6.0 times 10 to the minus 6. And then what was the distance between them? Between Q1 and Q2? Do you see it? What was it called? 2 centimeters, right? So 2 centimeters. So 2 times 10 to the minus 2. It's got to be in meters, and it's squared. So 2 centimeters squared. And then on your calculators, can you guys just crank that out?
Is it Q2?
Is Q2, sorry? Oh, this one right here?
Yeah.
That's 2. You're no kidding, yeah. So this one right here is 2. Thanks. That was Q3. Thanks, Lana. And then they're separated by 2 centimeters squared. And then get whatever this one turns out to be. And that was to the left. To the right. And then F3, same thing.
I got 135.
Pardon me?
I got 135.
Nice, thanks. Anybody else do? Okay, crank it away. Let's agree on an answer. We got 1 out. Thanks, Nick.
I got 135.
You got 135? Okay,
135.
so we get 2. Great. 3. So 135 newtons. Thanks, guys. I'm just going to change the color of this one back to black. Good. Thanks. And this one here, same thing. 9 times 10 to the 9. Q1, same one. 3 times 10 to the minus 6. And then 6 times 10 to the minus 6. And what's the distance between the two? Just going to back up for a second. Yeah, so what's this distance between here and here? Yeah, it happens to be 6 centimeters squared. So 6 centimeters is the distance. And then you got to square it. And that force will be to the left. Wait. Okay, everyone should be checking it out, cranking it out. It shouldn't be that difficult to do. We should agree on an answer. Like last time? 45. Anybody else do 45?
Yeah.
Okay, nice. 4 or 5, right? Yep. Okay, so we got 45. Excellent. So we got 135 to the right, 45 to the left. So what's the net force on that charge? So the net force.
90 to the right.
Yeah. It's 135 newtons that way, plus 45 newtons that way. So you're right. If you do it one minus the other, it's 9 newtons. In that direction or this one? Left or right?